Yeah? Okay. Do we have any questions about Abacus? How's it going? Yes. I was just about to find it because I did work through those questions. Okay. Um, I just gotta find it. Did I do it here? Not here. Um, okay. So the first one was I think I did it here. Oh, that's right. It was sorry, I apologize. It was the algorithms, right? You don't think it was the algorithm? Um, let's see. Okay, let's start off with. Okay, that was the picture. That was the addition, and then example. Okay, are we okay? Okay, so remember there was that one printout with the example, with the tens and the ones. Let me see if I can find it. Um, right. So it was share. Here we go. let's do let's do that. Okay. So can you see my screen? Oh, that's the wrong one. Yeah, that's the wrong one. There we go. All right, here we go. Let me move everything back out the other way. There we go. Okay, so um, so we had the bars. Did it make sense where the bars are going? Oh yeah, right, right. And in us, what we do is we make the 10, and then because we make the 10, then we have something left over, so it's easier for us to see on the abacus. Yeah, I thought that was a really good find. That was really good. And then we continued on with so that's why it's different, depending on the add-in. It always depends on the second number. So that the second number, right, there's the 3 over here. I don't know if you can see my screen. Let me see if I can annotate. It's always the second number over here that tells us what we're going to do. So just as we had before, you uh, to make so that's the thing. So to make the 4 a 10, right? We need to grab this information and put something here. That's what we're doing. Does that for the abacus? Yeah, for the abacus. Yeah. So, sorry, that's the 10 over here. And then what we're going to do is we need to add 6 here. But to add the 6, we have to minus from here. Yes. She puts it all together. Oh, yeah, you think so? I don't know. I have to look. Clear. So that's interesting. Oh, I need to clear all users. There it is. So she has it here, and then, oh yeah, I see what you're saying. I see what you're saying. Yeah. So she makes the 10 in the first one. Okay. Yeah, I could see that. Yeah, I see. Mm, I guess. I guess. True. No, not bad. It's just it's different. I Yeah, because it's choosing the number to make it the most, choosing the highest number to make it the easiest, which is which is interesting, which is interesting because what happens when there's more numbers? See, right now it's only two lines, so 48 plus 30, 34. Then when you have another, let's say we did all here. Oh, I see. Because they do ones first. They don't do it as a group. They don't do it as a whole. Hmm. Yeah, okay. Yeah, it's been a while since I've done like regular math, mainstream math. Yeah, because for Abacus we do a running total. We do it this way, and then we do this, and then we do that. If we were to add that total. Okay. So that was that one, and then the other one was explaining. Let me see if I can get out of this. Nope. The other one was her algorithms. So, but it's kind of the same because what they're doing is they're adding all of the digits. So they're growing up to 12. So they start with the ones place, and it doesn't matter if it's 10. It just spills over. So you never go up to 20, but you only go up to uh, 18, really, if you think about it. Yeah, trade. You write it out. Yeah. Here. So yeah, yeah, yeah. So stop, and then I'm going to. Can I do that? Okay, good. Okay, so funny. Anything higher than let's see, anything higher than the way she wrote it, right? She says anything higher than 9. That means 10, 11, 12, 13. Oh, can't see that. Hold on. Yeah. So what she's talking about is anything higher than 9. So not equal to 9. It has to be higher than 9. So yes, yeah. So So yeah, exactly. So it was like what? Let's do 8 plus 5, right? 8 plus 5 is 13. Because how do I know? I have 8, and then plus the 10 minus the 5. Oh, sorry. Right. So what she was saying is 13, and then whatever this is, she wants you to already combine it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we have this. So when she's talking about it, I'm assuming it's a she. Okay, so I'm assuming that anything greater, you still combine it, and then you have to trade. That's how I see it. You trade 10 in for a 10. Yes, correct, correct. But she's still counting up to 13. Whereas, yes, yes, yeah. But whereas on the abacus, we don't need to count all the way to 13 because we're not counting up, we're doing a concept, we're doing an exchange, right? No, the like technically, what? Technically, if we did this is equal to 5, what we're doing is we're trying to add 5 to equal to 10. We have to take away the 5 from here, right? And move it down here. Wait a minute. Oh yeah. Okay, okay. So I'm trying to workshop this one out. I'm almost got it, but I think it's kind of because we got to take the information from here. So we have their 8, and what we're doing is we're trading in. So their trade is we already know we're going to make a 10. We don't need to do the extra work of figuring out how to add the 2 more, because what we're doing is we have 1, 2, 8, right? We have 8, and this is 5, right? So what we're doing is we're taking this information and we're putting it here. So we're taking the 8 and we take the 5 from the 8 and we add it to here. And then this is the trading in that we're doing. So we add the 10 over here. But we have to minus it from the 8. That's what we're doing. We're taking it from 8 and we push it down because it's always the second number that dictates what we're doing. We don't do so. You know how in mainstream math we do right to left, and I said we could do right left to right. That's fine, right? To go if we have more digits. So if we have 34, 5 plus 8, 7, 6, right? It doesn't matter if we go left to right, right to left. But it does matter when you take from the first digit to the second digit, because that changes. It's always going to be this. It's always going to be the number coming into it. We always look at this number that we're trying to do, not this number. So the way she has it is, oh, it can be interchangeable, but we don't do that because what do we do is we don't do 8. I'm sorry. 1 plus 8 is equal to 10. We don't, or equal to 9. We don't do 8 plus 1 is equal to 9 because this is what dictates what we're trying to do. Right. So I was watching some other teachers that they were trying to teach, and what I noticed is they're like, "Well, we have to memorize our math fact at how to make a 9," and I'm like, "Why?" Because if we look, we have 1, and is there enough to add the 8? Yes, add the 8. And then it's again, if I want to add the 2, do I have enough to add the 2? Yes, just add the 2. So for Abacus, we don't need to, this is not a math fact for us. Yeah, exactly. Exactly. The only fundamental that we need to do is making sure that we know how to add the 5 and add the 10. Those are the only memorization that we need to do for us. As long as you know how to do these two, then you're set. Right? That's why I always go back to how do we make the 10 and how do we make the 5? And I know like the concept, obviously the concept is different because mainstream talks about it. And that's the other thing. Mainstream, there's no structure. They're just like, just memorize it, just memorize it. It's like, wait, no. I mean, you can logically think like, what are we trying to do here? We're gonna add the 5, yeah. So that I think that's what I would have to do is 1, 2, 3, 4, 5, 6, 7, 8, yeah. So then this would be the number, right? So we have 8 on the abacus, right? And that's what we do is we take the 5 from the 8. We take this 5 and we give it to this 5 to make a 10. So then we do that trade. Yep. Yeah. Yeah. So that's what she was saying there, and that's the difference between what we're trying to do. Algorithm. Yep. Yep. Hold on. Let me see if I can find it. There we go. So, oh, sorry. Share. Okay. I'm in the wrong one. Okay. Oh, there we are. So, the subtraction one, again, you start with the ones place. Is the top, right, is the top greater than or equal to the bottom? So here's the difference is when we're subtracting, you cannot take away, we're in, right now, because they're young, we don't do negatives. So if we did, let me get a nice question. Yep. Yep. So I don't know if you could see my paper. So we're not necessarily. We still just look at this part here. Can we take away from the 2? No. So that's what, yeah. And so, but then she's like, you need a trade. If it's a no, then you need a trade. You need to take this one and you need to put it here. How do I differentiate? It's kind, the interesting thing about her algorithm is that it doesn't, it doesn't, it doesn't really have a good example here. It would be better if the example was like 48 take, maybe do this one, 48 take away 6. Maybe that's a better one. Oh, sorry, 30, yeah, 34 take away 9. Let's do that. 34 take away 9. Maybe that's a better question, right? So she, she talks about trading. So you have to, let's do it. Let's do 30. 1, 2, 3, 4. 1, 2, 3, 4. Oh, 3. We need to 3. So we want to take away 9. We have to take away, yeah. We have to take away the right. We have to take away the 1. We have to take away the 9. But to take away the 9 from this group, we have to break this up, right? To break this up, what happens? I'm left with 2, right? I'm left with 2. And then this becomes 10. 2, 4, 6, 8, 10. Now I could take it away. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm left with 5. Does that make sense? So that's how, yeah. Yes. Yes. Mm-hmm. You're, yeah. Mm-hmm. Yeah. So now your memorization in mainstream gets bigger. But now if we did it Abacus way, I like to change colors. I'm going to change colors. Let's see if this works. So that's why I'm going to go back. Yeah, no, I'm confused. Like that. Okay. So thank you. I do appreciate it. I like labeling too, right? So we have our 34 minus 9. Well, what do? We have to minus the 10. We know, yep, to add the 1. We know what? So we do 34. We're going to substitute this in. We have to minus the 10 plus the 1. So if I did it row by row, 34, I take away the 10 and I plus the 1. Oh, yeah. Yes, that and also and also we compound our information because what do we know? We know if we want to add the 9, it's the same thing but the opposite. We don't need to know 14 minus 9. We don't need to memorize this. What we need to memorize is this concept, which is only 2 things. If I know how to add, I know how to subtract, right? So let's say, yes, but let's take it one step. Let's take it one step down. Let's do 33 minus 9. Well, now what? Now we got to do it again. We have to take away the 10 from here, but now we need to know 13. 13 minus 9 is what? We have to remember that 4 is equal to 13. But here we go back. 34 or 33 minus 9 is what? We know this concept. We do it again. It goes to, that's really interesting. But yeah, right? So when we start incrementing, we don't want to have to memorize all of this because we just need to know this part here. That's why it's easier. That's why it's easier. That's if it's together. That's if it's one right after the other, you will see it. But if it's jumbled up, right? If I did I don't know, 72 minus 9, right? You got to do the same thing. I got to make a 12 out of this, and then take it from here, right? So we can take it another step. What if we did 97 minus 9? You got to know 17. 17 plus 9 is what? That's a really good comparison. I'm going to make a post out of that. That's a really good post, right? So if we did a comparison, this is M, right? And if we did the A, so A, 72 minus 9, guess what? Minus the 10 plus the 1. Do it again. 9, take away 9. Minus the 10 plus the 1. It's the same thing, right? So we just need to memorize this one thing and we know how to do it. Yep, exactly. Well, yeah, but we know that if we need to add the 9 or take away the 9, but see, now it's different. Let's say we added. Yeah. Oh, yeah. Yeah. It's greater than 4. Correct. Anything, adding and subtracting. If I do 9, I'm never going to use the 5 because there's no partner to make a 5 with a 9. The focus is how do you make a 5? We're not going to subtract 9 from 4. We don't do that. No, the second add-in. Oh, wait, what are you talking about? You're talking about this? Hmm. No. So if we did, yeah, because if we did 16 minus 4, this second add-in needs to be a minus 5. I'm sorry, 96 minus 4. The 6. Yeah, exactly. You don't have enough bead from the 6 to subtract 4. That's why you do 5. See? Yes, but because you can see it, you don't need to memorize the number that you're looking at. Because if I showed it to you, you're like, oh, I need to minus the 5. You knew that already because you saw it. But now when we do this, it's like, well, these are symbols, and the symbols you have to translate it in your brain, right? That's why it's different. That's why if you could see it, you know what to do. So, so if we did, so even if we did the other way, so let's say we did 97 plus, no, not now. Let's do 8. Let's do 8. Let's do 8 for just to keep up. So if we do the 9, right? Well, they count up. They add everything. They add this together to make 16. And then they take this and they put it into here. So it's still the same thing. Whereas like if we did 72 plus 9, they count up to 11, and then they take this and they put it into here. That's mainstream, right? But what do? In Abacus, it's 9 plus the 10 minus 1. Yeah, right. So it's not it's, yeah. And then we do it again. 72 is equal to plus the 10 minus the 1. So because we know how to add, we will know how to subtract. It's not a new set of information. We're just modifying, pivoting it a little bit. This is new information. Like 16, I would have to memorize that. But then let's take it one step further. We do it again. We can do it again with let's do it again with 8. It's the same problem, because if we did 87, let's do 87. 80 uh, if we do 87 minus 8, 9, right? 9 take away, I don't know, 7. But in Abacus, we know that 87 minus 8 is what? Minus the 10 plus the 2. Yeah. But see, now you have a whole new set that you have to memorize. 8 plus something is equal to 17. 8 plus 8 is 16. 8 plus, you know what I mean? So there's a whole new set. So you have one set of how to do the 9, and then you have a whole new set of how to make an 8, and then you have a whole new set how to do a 7. So then you have what? Yes. Yes. Yeah. Yes. Mhm. Mhm. Yeah. Yeah. But that's a whole lot of memorizing. Right? Yeah. So, and that was interesting. Yeah, that's going to be another post because I don't want to have to memorize all of this. I don't want to have to memorize all of this to just get this. In comparison, that's a lot of, yeah. This is this is all you need to know how to add and subtract. As long as you know these two sets, that's why I think that's what makes Abacus superior, easier. But yes, and it is a different way of thinking because it's always about the second number. Oh, sorry, second number. Yeah, that's crazy. That's a lot of memorizing. Yeah, I could see that. I could see that. Yeah, because I did the number bonds. I was trying to do the number bonds for like Abacus and stuff, and so um, this that's all the number bonds we need to know. I'll go back and I have to go back. I have to go find our last Zoom. I think I recorded it. I'm not sure. I think I no, because Zoom has its own recording, and I don't know if I recorded it. There was one time I didn't record. I was like, no, it was a good one too. Um, it might have been last week that I forgot to hit the record on my Zoom. Yeah. Okay. So I'll see what I can find and see if I can figure that out again. But yeah, so all of the number bonds, these are all the number bonds we need to know. That's it. As opposed to everything else. And then what did I do? Oh, I was trying to do more questions. Email? Yeah. Yeah. I worked it out. Oh, was it something like this? Yeah, 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 yeah. Yeah, that's why I like paper and pen so I can always go back to my notes. Somebody was like, "You should use an erasable," and I'm like, then I'll never know what I'm doing because I still think, yeah, yeah. So, so that's what I was trying to do is I was trying to show you what algebra is. So we changed our x's to an unknown variable, but it's a abacus is a leverage that feeds into it. Like you know your number, but if you can see the pattern, then you can start taking and make it a variable. Yeah. Okay. Good. Good. But yeah, I was going through. Oh yeah. See. So I did do it. So here was the first question, and I did left to right and right to left. Just to practice. And so we had 213. And then we did 3. Right to left. Excuse me. So right to left, we add the 5, and then we add the 4. Adding the 4, you can see it. You need to add the 5, right? Plus the 1. And then here is the 3. You know to do it again. Plus the 5 minus the 3. Yep. And then the other way is exactly the same. The reason why is because there's no carrying over. So it doesn't matter if you go left to right, right to left. So anything if you add the 10, if you add the 5, it doesn't matter. But it's when you go 10, that gets a little bit interesting. That's when you start seeing it. When you borrow or you carry over. So if we had 2, 1, 3, and then we're going to go this way. We have 3, add the 5 minus the 2, add the 4, add the 5. Nope, add the 5. Add 5. Yeah. Yeah. Yeah, I did that too. One time I had a question. It was like, I need to take away the 6. And I'm like, I can take away the 6 minus the 10 plus the 4. I was like, wait a minute. Or something like, it was something like this or something. And I was like, wait a minute. I don't need to do a formula because it's right there. Sometimes we forget. Yeah. Yeah. So we have 194. And then we do 4, 2, 1. We could do 0. We add the 2 is what? Plus the 10. Yep. Because why? Because we're already using the 5. So we know we're going to do the plus the 10. But it's nice to see it, right? And then we plus the 4. Plus the 4 is plus the, yeah. So the difference here is because of the 10. So if we did it from right to left, we do it this way. 1, 9, 4. We add the 4 plus the 5 minus the 1. Add the 2 plus the 10 minus 8. And then 0. Yeah. So we have 9, 4. Oh, I'm sorry. Yeah, so we're doing it left to right, right? So add the 4, add the 2, 0. Yeah, yeah, yep, 4, yep, right. And so this one was so from left to right. So the difference here is just whether we go left to right or right to left. This was not to talk about the difference between mainstream math and abacus, right? So here we go from right to left. It's plus the 10 minus, and then 7. That's add the 7. Yeah, I did the same thing. I was like, wait a minute. And then plus the 1. Add, there you go. So the answer is 791. 700. 700. Yes. Yes. Yeah. What? I don't know what it is, but it feels more natural going from left to right. It just feels more natural. But I have been trying to go right to left. So if we did it again, we do 6, 1, 6, and we go from left. We add the 1, add the 7, add the 7, and then yep, 7. Oh, I wrote that wrong. Yeah, yeah. Or yeah, you still got to go back to go forward. Yeah. Mhm. Yep. Or yeah, that's what the carryover is, and that's why it's still easier, just because we know we're only carrying over the one bead, the one column. And then having said, oh, 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 yes. Yes, yes, and that's what it is. But you won't know until you do it both ways, and then you see it. So then the other thing is in abacus you could do 5 is equal to minus the 5 plus the 10, so you end off in the middle. You could do that, right? So if we had 6, 1, 6, we have the 1, we add this 10, 10 plus the, anyways, 9, right? No, 8. It was 8. So we can do is minus the, so we're here, we want to add the 5. You want to minus the 5 and then plus the 10. So you're in the middle. You could do that. Okay. Mm-hmm. This one. Yeah. Not necessarily, because sometimes that's where you the two step. So I don't know how she does her mixed formula, but the problem, the one that I do see is it's good to be flexible because sometimes this number it needs to be and sometimes this number needs to be. It just depends on where you are in the process. So like our like here, right? Our 10 can be adding, but then was it we can either do plus the 10 plus the 1, sorry. We can either do plus the 1 is equal to plus the 10 minus, or it can be what? Plus the 5. Yeah. Then this one, like, yeah, obviously it can be either minus the 3 is equal to minus the 10, or it can be, yeah. I don't write it out, but I chant it out. I chant it out. And I think I'm going to keep it as chanting it out. Yeah, I'm going to keep that. Yeah, but just as I explained to you how we made the 10 and so forth with the 8, I think that's a good supplement. That's a good addition when we take the 8 and we move the 5 over here. I think that's a good supplement. But I think chanting this out is still very good. Yeah. And so, but yeah, again, it I believe to be flexible. So we could do minus the 9 plus the 10 or minus the 4 plus the 5. Because it depends on where you are in the process of adding and subtracting on the abacus. I think, yeah, I think there was too many rigidity. There's too much rigidity if you can't be flexible on it being this interchange, because they do it in mainstream math, right? Mainstream math, that's why they got the number bonds. Why can't we do that in why can't we take this concept of, yeah, yeah, yeah. So if this is interchangeable, why can't we do that for that? And that was the reason. That's why, like, it's great that she probably does it because it's the beginning parts of the questions, right? It's the beginning part of your journey. But if you go further into it, I believe you should be very flexible. Do you need to add the flexibility now? It's up to you. Yes, yes. And the reason why I do it is because I wanted to relate to mainstream math. And and we as growing up, we've always started with the right. So completely new to Abacus, I don't want to disrupt too much of understanding this. That's why I started with the right, and then I'll show him how to do it with the left. That was my thought process on that. But yeah, as you do more Abacus, you'll notice that left to right it just seems more natural. But it does take time. This one? Oh, I don't know if I did story problem. Oh yeah. Um. Okay, go ahead. Let me see. think I added it to this one. Is it here? No. Oh, here it is. So, yeah, I just need to make it bigger. So this one was kind of like, yeah, I started adding word problems to some of my activities. So the first one is if you had 40. I'm gonna make this bigger. Yeah, and then yes, I was going to add more story problems. I was going to add more concepts to it, which is really kind of interesting. I'll show you. I'm actually quite excited. So the question is 40, if you have $40, so I'm going to write $40, and then you spend $6, how much money do you have left? So back to here. So a lot of it is just trying to figure out what they're trying to say in the question. So if I have $40 and I spend $6, I know I'm going to be minusing. So the question would be 40 minus 6. And then what do? We do take away the 6 here. Plus the 4. Yeah. So we take away the 10 plus the 4. So the difference is what? In Abacus, we don't need to cross this out, right? We do it already. Yeah. Yeah, it's shown on the Abacus. So we don't need to, so we just do in 34. Okay, so the next one is 40, and you earn. Earn means what? You earn $5 is you add, right? So this is an adding. This is subtracting. Yeah. See, now you know, right? But because before, if we had the 4, we would have to be like, okay, 5, add the 5, 41, 42, 43, 44, 45. But here we just add the 5 because the Abacus tracks it for you. So that's why when I looked at it, I was like, huh, that's interesting, that the word problems. So Eden does 35 jumping jacks. Jumping jacks, right? And then we do 20, and then she does 20 sit-ups. The question is how many exercises does she do? How many exercises? So what does that sound like? That sounds like it's an adding. So all we have to do is 35 plus 20 is what? So we have 35, and then we add the 2. We add the 2, 20. We know. Yeah, see? You're sounding more automatic now. Like it's more, it rolls off your tongue more. So my final answer is 55. Yeah. Give me those questions and we will go through it. So it's the same thing, jumping jacks, right? Jumping jacks, and then 20 sit-ups. Then the question is what? How many more jumping jacks does she do than sit-ups? So if it's 35 minus 20, that's right? Take away 20. Can I do it? Yeah, yes. But you have to translate this in your head. Whereas on the Abacus, you don't have to translate. It's already displayed. Caden plants 13 inches. No, Caden's plant is 13 inches. So there's 13 inches. Olivia's plant is 17 inches. How much taller so we have to know what? How much taller is Olivia's plant? This is Olivia's plant. and this is cadence plant. So we need to know that 17 will be higher than 13. 17, 17, take away, so we need to minus, right? Minus the 1, minus the 3. Minus 3 is what? Minus the 5 plus the 2. Minus the 5 plus the 2. Jason has a ribbon that is 34 centimeters. James's ribbon. Yeah, James. Okay, no, that's fine. He uses 12 centimeters. Yes. And then the question solidifies it. How many centimeters are left? So 34 and then 12. So this is easy because it's what? 34, take away 1, take away 2. Yep. So you're centimeters. Yeah. Yeah, it's funny. Exactly. Exactly. And the more you see the numbers, you'll notice how they like how mainstream overcomplicates all this stuff. It's really interesting. Okay, so the next one was it is 34. So 34 coins, 34 golden coins are in one sock, and 7 coins in another. How many altogether? All together, right? So it's 34 plus 7. 34 plus 7. What's plus 7? Plus the 10. Yeah, plus the 10 minus the 3. My answer is 41, right? So then the other one was, sadly, 34 coins are for Boney Bill. How many coins are left for me? I don't know what that means. Hold on. Let me. Yeah, I'm not. I guess, sadly, 34 coins. So you're taking away. So, okay. So if we go back, 34 is Boney Bills. Boney Bill. So we're going to 41, take away 30, right? Take away 3, take away 4. What's plus 4? What is minus 4? Minus 4 is what? Minus? Yes, minus the 10 plus the, yeah, minus the 10 plus the 6. See, they were trying to get you to add the 7, take away the 7, but it's not, because this is different. Do you see that? So they're trying to do 4 plus 7 is equal to 41, but then if you minus the 7 is equal to 34, kind of a thing. That's what they wanted to do. So they're focusing, so they're focusing on the result. We don't. We focus on the second number. That's the difference. Yeah, because they're trying to get you to, they're trying to show you that it's interchangeable, but it's not. In Abacus, it's not interchangeable. So let me rewrite it, because I did have one activity, I'll show you in my other one, where we have 7, right? And then it's equal to 41. They want to take this 41 minus 34 is equal to 7. They wanted to show you this number, I don't know, this number bond of 7 and 34, right? So I incorporated that concept, but not the way they have it. So in here, the way I have it is I do it with the minus the 4. Yeah, this one's the plus 10 one. Minus 10. Yeah, this. So this is what they're doing. They're showing you how to check. So I was incorporating how to do it in Abacus. So I said 13 minus 4 is equal to what? It's equal to 9, right? And then how do I add it to get to my number? So then you see if I add the 9, am I going to plus 4 is equal to, and then what I'm doing is I'm trying to show you that the 4, yeah, the 4 is what we want to what we want to focus on. The adding the 4 and the minus 4. Right. Yep. Wait. 13 minus 4 is yep, the 6. Yes. Oh, you know what I should do is right here, I should put in a thing saying write the formula. I should write the formula. Yeah, you did. Say it again. I should do that. Minus the 10 plus the 6. Yep. So then what do we do here? So this is 9. So what do we do here? Yep. Plus the 6. Yep. I think so. I'm going to update it so I have a space for writing the formula. Yeah. 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 I think that's what I'm going to do. I've been updating my books. It's just such a, yes. Oh, yeah. So we're back to here. Okay. So the next one was 49 plus x is equal to 53. That's the question. So we know that that would be a what? You know what you need to do is isolate the variable. 9 plus x is equal to 53, right? So we need to isolate the variable. To isolate the variable, what do? We have to take this and we have to minus, yeah. So to make this 0, you have to take it away. Do you see that? Yeah. Yeah, cancels out. So yeah, this cancels out, this becomes 0. So now we know 53 minus 49. So we have 53, take away 4, plus the 1, and then minus the 9. 9? Yes. Yeah, that's what it is plus the 1. Yeah. And then minus the 9. Cannot take away 9 here. What do I do? Yep. Minus the 10 plus the 1. So my final answer is 4. So x is equal to 4. So then you rewrite it. 9 plus 4 is equal to 53. Yes. Yeah. 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 It's interesting when you start making revelations like, why don't we take away the 1 right away? You wait till you're done with the number. Yes, exactly. Yes. Yeah. But so mainstream 53. Yep. Yep. Hmm. Yes. Step by step. Yes. Thank you. I appreciate that. I do. I appreciate that because I'm trying to explain it. But you know what? Funny. It's because uh, I was going through it in my head before. So you're going through the same process I went through when I was trying to figure out like how is it different from mainstream to um, so when we do minus, right? When we if we go here's a question. Are we going left to right or right to left? That's the other question. Okay, so if we go left to right, then what we're going to do is we're going to minus the 1 first. So what happens is we have 1, 3, minus 9, because we minus the 4, 5, 3. So what do we do? We minus the 4 is equal to minus the 5 plus the 1. So we're left with this. This is our running total. We still have to minus the 4. Yeah. Yeah, it's showing 2 steps, but it's showing you step by step, actually. So now we are left with 13 because we've already taken away the 4. We just need to cross out the 4 because we've already done that, right? So we're still left with the 9. When we take away the 9, we know we're going to minus the 9 is equal to plus the 1. Yeah. Yeah. So when we replace this, let's say we replace it, let's substitute it. 13 minus the 10 plus the 1. Yeah. Yeah, because what are we doing here? We're substituting, right? This becomes substituted into here. So this is what we're doing. Yeah, this was crazy when I did that. I was like, oh my God. So yeah. Yeah. But to write it out like this, I was like, oh my God, this makes so much sense. Be- Mhm. Yeah, does that make sense? Yeah, because we're used to seeing it horizontal. It's different than vertical. Made it horizontal. Yep, 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 yep. Um, it's kind of there, but I didn't want to confuse anybody. I didn't want to, yeah, I didn't want to confuse anybody. I might add this into the adult version, but I don't think I'm going to do it for the kids version. Because, yeah, yeah, is my way of writing, yeah, it's my way of writing it out on a piece of paper. That's the only reason why I did it. Right, to explain it what I'm trying to do. Because what I would do is I would just do 13. I go minus the 10 plus the 1. But to visualize, like, because we're very paper oriented, I want to show you the different way of doing it. Yeah. So that was interesting. But yeah, and so in and because we're doing it this way, kind of follows the mainstream that way. Kind of. Yeah. But not really. Yeah. Uh-huh, yeah. Oh, I see. Uh-huh. Yeah. So it'd be like that. Yeah. Mm-hmm. Yeah. Mm-hmm. Yeah. 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 But well, see the difference between what we're learning now and what's going to happen later. This doesn't happen until later when it gets when you become solid with the formula. So doing this wouldn't necessarily help because if you notice, I go through like single digits until we get solid, and then we go into double digits. No, I don't show the only double digits I show is maybe the teens, but I don't do double digits until the next book, the next concept. After the it's going to be part of the two step. No, this one's another one. I so plus adding of the five has word problems. Subtracting the five I forgot, and then adding of the 10 I think I forgot. So yeah, minus the five I forgot to add in the word problem. Oh no, I did. I added word problems. I think it was the minus the 10 I forgot. I think adding of the 10 I forgot to add the word problems, but I added the puzzles. Yeah. And so then I was like, wait, I forgot word problems. So I went back to word problems in the 10, in the minus the 10. And I'm trying to keep a formula of what I do and what I don't do, and I just forgot to keep my list. Okay, yeah, this one just came out. There's this one that came out, and then I have a 4-digit maze book. So did you see? So that just came out too, and then I was working on the adding of the 10. So after this would be the two step. After this is two step. So I need to continue the Who series to continue on with the two step because this is not done yet. And then once I finish the two step, then I'll start going into double digits and triple digits. Yeah, yeah. But it's going to be exactly the same, and it'll be fun. But it won't be separate concepts. Every book will not be separate concepts because you should know those concepts already. You should know how to add the five, take away the five, add the 10, take away the 10. I'm just going to put it in a double digit format. So I think that's just going to be one book. I'm going to add in the lessons, but there will be more compacted. If you follow the Who series. But then what I was going to do after I finished the Who series, then I was going to go into section the books as by grade. This is what you do for grade one, single digit, double digit. Grade two is double digit, triple digit. Grade three is whatever, 3 digit to 5 digit. But they would still follow the same path, adding the 10, add the 5, minus the 5, add the 10, minus the 10. But I don't know if they're going to be two books or one book when I do the double digit for the grades. I don't know. I haven't figured that out yet. But that you won't. Yeah, I could. Yeah, I can combine it. But then the problem is I don't want the book to be too fat. So that's why I'd be because I want to try to keep the books like 100 pages because then it gets the kids to be like, I've accomplished something, you know. So then after understanding how to do, so understanding how to do the plus the 10, you can go into cumulative addition. Where do I have it? And I was going to actually start that. I should have started it in the adding of the 10, but I forgot about it. Whereas we start doing times table. But to do times table, you need to know your adding of the 5 and adding of the 10. So this would be, 2 plus 2, 2 plus 1, 2 times 1 is 2, right? And then this one is 2 times 2. 2 times 2 is 4. 1, 2, add the 4. And then you need to add another 4, add another 2. What is 2 times 3? 2 times 3 is plus the 5, 3. Yep. And then we do it again. 2 times 4. 2 times 4, can we add it? Yes, we can add the 2. Then 2 times 5 is what? Plus the 10, right? Minus the 8. And then 2 times 6 is 12, right? And then 2 times 7 is 14, right? And then 2 times 8 is plus the 10, plus the 5 minus the 3. So we get 16. And then 2 times 2 times 9 is add the 2. Yeah. So I should have added this in for the plus 10s, but I didn't. Because then it would be the beginning parts of multiplication. But yeah, I would have to update. I'm gonna update it. I think I'm just gonna create a new book. I'm not sure. But for online class, I need to add this in because you could do the same thing with the 3, 4s, and 5s. But then when you get to 6, you need to know your 2 steps. Yeah, 6. Yeah, so let's do it. Yeah. We'll do 6 times table. So we do 6 times 1 is 6. 6, 2, 3, 4, 5, 6, 7, 8, 9. Right? This is all 6. So 6, 6, 6. Okay. And then, so we know, and I think this is how I was going to set it up, like this, and I'd have like I live very close to the fire station. Oh, you can't hear it. Okay, good. Okay, good. Good. So we have 6 times 1. 6 times 1 is 1, right? This 6 times 6 plus 2. 6 plus 6 is what? Plus the 10 minus the 4. Plus the 10 minus the 4. Minus the 4 is minus the 5 plus the 1. Minus the 5 plus the 1. See, right off bat, that's a 2-step equation. That's why you need to know your 2 steps before you do additive addition. So 6, again, add the 6. I add the 6, right? We're okay with that. Now here, we want to add the 6 again. Add the 6 plus the 10 minus 4. Can't do it. Plus the 10 minus the 4. Can't do it. Minus the 4 is minus the 5 plus the 1. Minus the 5 plus the 1. We need to add the 6. Can we do it? No. Plus the 10 minus the 4. Plus the 10 minus. Right? And then yeah, exactly. And then we do it again. Plus the 6 is equal to plus the 10 minus 4. Plus the 10 minus the 4. Yep. See how you have to really know your formula. And then we add the 6. And then finally, plus the 10 minus 4. Plus the 10. See, now there's more. We have this is what? Plus the 5, right? Plus the 5 minus 4. And then plus the 4. Minus the 4. Minus the 4 is, yeah. Why? Because when I look at it, if I have 12, do I have enough to add the 6? Yes. 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 It's always, do you have enough to add the 6? That's why. Yeah. Yeah. You know what? I haven't figured that out yet. I haven't done this long enough, but I didn't I haven't done this long enough to figure out if there's a pattern. I don't I don't know yet. Mhm. Mhm. So I forgot to introduce the beginning parts of adding cumulative addition, because what is it? It just means that multiplication is just fast addition. We just did shortcuts. Oh, shortcuts. So this is a shortcut to addition. If we do multiplication, at understanding your multiplication fact family is a shortcut to doing multiply. Oh, yeah. Shortcuts. Okay. So we say in mainstream, we say we need to know our multiplication fact because it's a shortcut to addition, right? We know that if we know 6 times 9 is equal to 54, that's a shortcut. This is a shortcut of 6 plus 6 plus 6 plus 6 plus 6 plus 6, plus 6. That's a shortcut. Abacus introduces shortcuts early because we know instead of doing 12, we do 12 plus 6. Instead of saying 6, 7, 12, 13, 14, 15, 16, 17, 18, instead of counting it, we know the shortcut is plus the 10, minus the 4. This is our shortcut. So we introduce shortcuts early on. that's why that's that's why the concept is relatable and it's transferable. Oh, that's brilliant. But no, 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 we don't recognize it because it's never been thought that way. Yeah, we talk about it in multiplication that this is a shortcut. Yes, we talk about that, but I never nobody has ever mentioned that abacus is a shortcut to, because I do know that when we do number lines, what a pain in the rear on that one. So we do 12, right? We do 1, 2, 3, 4, 5, 6. So what we're doing is we're always doing 1 to 1. That's 18. So this is 6, right? So we're doing a 1 to 1, and it's always counting up. We're always counting up. We never use a shortcut to make a 10 or make a 5. Yes, every number. Yeah, yeah. That's, yeah. So this is mainstream, right? This is mainstream, and then this is abacus. Mm-hmm. Yeah, it's interesting. Like, and that's why I'm here. That's trying to figure out how to get whatever is mainstream to abacus. And I tell you again, I do appreciate your conversation with me because it does spark so much connections for me, like how to bring it to light. Thank you. I appreciate it. Yeah. Okay. 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 I appreciate it. I appreciate, and you're right. You're absolutely right. It's always nice to hear what the other person is saying because the connection, what you're trying to go through and what we're trying to talk about, it doesn't help when it's only one sided. So I didn't, I found that out like later on. I'm like, oh my gosh, because when I do my TikToks, there's nobody on the other side. So that's the limitation of StreamYard is that it doesn't capture the vol. It doesn't capture the voice on the other side, the sound on the other side. I have to because because I recorded Zoom. I can take the Zoom and I can upload it to YouTube. That's what I have to do. But see, other people, what happens is they're sharing not Zoom, they're sharing a web page, and you could share the sound on the web page. That's the difference. So I'm trying to share my sound through another application, and that and they don't do that. Yeah, correct, correct. Because it captures from my microphone. Yeah, yeah. It's a little sad. I'd have to figure out like another application that will do sound on all platforms. I I did? No, you did it? Oh, then if that's the case, then Zoom is then StreamYard is a little finicky because sometimes the volumes will cut out, and that's what makes me mad. Like I try to when I try to do TikTok my TikTok lives, sometimes I can hear my voice, sometimes I can't, and I just have to end it. Yeah, and I have to end it. Yeah, yeah. So if you don't see me on YouTube and you can't hear the sound, then I cut out, then I just turn it off because there's no point. So what I want to do, but the other reason why I want to try to do is bring my TikTok lives to YouTube because I have sound effects. Yeah. So um but yeah. Oh yeah. Yeah. Yeah, but see the difference between like what we're doing here is because we're going more into it. I don't have to talk about the beginning parts. So I mean, that's why it's nice to have like TikTok just so I can practice like the beginning parts, but I like this because we can start deeper dig deeper into understanding the difference between mainstream math and abacus. Yeah, yeah, but they're not in depth, right? They're just kind of this. No, yeah, yeah, because don't forget the people that are coming on TikTok. They're all new. So it's like the first day you met me, you didn't know what's going on. But as we continue to talk, I mean, this is what 10th or 20th time that we're together. So you have a stronger foundation. It's easier to talk to like the higher concepts. Whereas in TikTok, it'd be the same thing over again. I just be counting. I know how to count really well from 0 to 9. And I've always been worried about like what am I going to say, but I noticed that when I produce the content, it's the same thing because it's always going to hit somebody else. So I just count again, just every time. But that's why I enjoy these conversations because we can dig a little bit deeper into the theory behind mainstream math and abacus math. Yeah. Yeah, because this part here I would do on my own, right? And I would really think about it and be like, okay, why are they doing it this way? So it's nice to have like somebody to talk to about it. Yes, feedback. Yeah, like bounce ideas off. So, oh, that was the other thing I wanted to show you. There was another thing. So, depending on how far I go with the whole abacus thing, I don't know. I'm still figuring this out. Is like you can actually use abacus for how to find the interest rate, but you need to know the concepts. And that was another thing I was going to introduce exponents. I'll show you about that in a little bit. So the question is I have 6,700 invested in the simple interest mode. This is not for kids. This is for a little bit older, right? But the idea is after 3 years, the total value is 7,162.30 cents. Determine the interest rate. So now what we need to do is we need to understand the concept. We need to set up our question. We need to find the interest rate. To find the interest rate is 7,162.30, which is fine. And then we just need to subtract 6,700. So I'm going to subtract 6,000 and then subtract 7 minus the 10 plus the 3. So my final answer is 462.3. So we know how much we gained in interest. Now what we need to do is we need to figure out what is the interest rate. To find the interest rate, we know our interest is 462.30 is equal to P is the principal. Principal is 6,700. The R is what we're trying to find, and the T is time. The time is 3 years. So when we do is we're going to clear this out. We're going to distribute the property. This is how we do multiplication. We did multiplication, right? 6 times 1, 2, 3, 4, 5. 6 times 3 is 18. 1 and 8. And then 3 times 7 is 21. 21. Add the 2, add the 1. Add the 2 plus the 10 minus the 9, add the 1. So my final answer is 20,100. So we have R, but we need to isolate the R. To isolate the R, we need to divide 20,100 divided by 462.30. So when we work it out, we can do the division, and it comes out to be 0.03223. But it's the concept. Oh, so I would have to change it for this one. Okay, so we can do a little bit of division. So division is, so when we do division, but take it one step at a time, right? You'll understand how to multiply, you'll understand how to divide. So the first thing we do is we need to find our starting point. We have 3 digits, 1, 2, 3 in our dividend, and we have 5 digits in our divisor, 1, 2, 3, 4, 5. I have to set it up this way. 3 take away 5 is minus 2. So when I put it on my abacus, we have to count 1, 0, minus 1, minus 2. So our number line this is our number line. So this is where I would be. That means I need to, oh shoot, I should have did it over here. Sorry. 1, 0, minus 1, minus 2. Why do I need to do this? Because I want to put my divisor on the abacus. 4, 6, 2, 3. 4, 6, 2, 3. Now the first thing we're going to do is we're going to understand, now I have to set it up. 2 times what is equal to 4? Because I'm over here and the 4 is bigger, I need to skip this column. So 2 times 2 is equal to 4. So I take away the 4. 2 times 0 is 0. 0 is a single digit. Take away 4. 0 is a single digit. I take away 0 here. And then 2 times 1 is 2. 2 is a single digit. I take away 2. Okay, now I'm done. So I got to count it again. where are we? Here we go. What times 2 is equal to 6 or less? 2 times 3. But because I can divide it out, I have to skip this. So it's 2 times 3 is equal to 6. I take away the 6. 3 times 0 is equal to 0. 0 is a single digit. I go back one column. 3 times 1 is equal to 3. 3 is a single digit. I take away 3. So then my final answer is 1.021. 3. 0.023. And that's my answer. Because I said that this was my ones. When we get there, it'll be easy. But right now, you're jumping into something that's a little bit higher. Yes. 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 Oh, see, that's why if we were to really do it, I would give you like something like this. This is what we would do. This is the beginning parts, right? So we would do 2 digits, take away 1 digit is 1. So you start here. What am I going to do? I got to put my divisor here. Put 90, I put 8. And then what do? Now I compare. Now I figure out my question. What times 2 is equal to 9? Because I can do this, I have to skip one column. I have to be here. What because I can divide 2 into 9, I have to skip this column. That's it. I have to skip this column because I can divide it. Because I can divide it, what times 2 is equal to 9 or less? So I add my 4 here. My quotient is here. Right? So what do? 2 times, yeah. No, my minus the product. 2 times 4 is equal to 8. I have to take away 8. So I take away the 8, 5, 6, 7, 8. And then what do? Now I compare. Now I have to check to see my answer. I still have dividends. So the question is 2 times what is equal to 1? No, I can't do it. I have to make it 2 digit. 2 times what is equal to 18 or less? 9. So I add my 9 to my quotient. I take away 1. I take away 8. So my final answer is 49. But it's all about the numbers. If it's too many numbers, there's a lot of things going on. Yes. The quotient. Yes. To the other side. Yeah, like that. Yeah. Yeah. Paper. Oh, yeah. Yeah. Yes. It's only challenging because it's unfamiliar. It's only because it's unfamiliar, because it's a different way of thinking. But it's actually a lot easier because when we start getting into double digit, it's so much easier doing Abacus way of double digit. But I have to show you the the fundamental first before I go into the double digit. So after doing 2 digits, we do 3 digits. After 3 digits, will be 4 digit. After 4 digit, you do it enough times, then we do 2 digit. But that's the plan. Yeah. Yeah, yeah, yeah. Because you practice, right? You'll understand the formula. You'll understand what you're trying to do here. But you'll notice what we do is we do multiplication. We find the missing factor. That's why you need to know your multiplication facts. You need to know your multiplication solid. Because if you notice, we never say how many times does 2 divide into 15. Well, if you Yeah, so if that's so then you're going to have more than five, eight. So we take away, you said six. So we would take away one, take away three. So what do we have left? We're going to do three. So then you're stuck because three, you can take two times what is equal to three or less. Since you can take away three, you're stuck. So you know you're doing something wrong here. So you have to So you add the 10 here, or you add the 1 here, and you just take away the 2 here. Ha! Ah! 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 That's brilliant! Oh, that's brilliant. Okay, got it. Okay, so yeah, so we're going back to 15, right? Okay, okay. So another, it brings you back to the loop. So you said you had 6, right? So we have 3. So yeah. So the question is 2 times what is equal to 3? Well, I can do something. I got to go back. So I was going to be here, but I got to go back to here. I need to plus the 1 here. Add the 1. So then it makes me 7. So it's actually 2 times 7 because this is 1. 6 is already on my abacus. 2 times 1. Yes, yes. Add the 1, take away the 2. Yeah. Nope, that's a good question. That's a good question. So then you're left with 1, and now you can't do anything. Or you're left with 1, sorry. I got to figure this one out. But you're left with 1, right? Take away 2, you're left with 1. So then we're back to 2 times what is equal to 1. Can't do it. You got to bring down the second number. Oh, that's a good practice. That's a good practice. Okay. Because what happens is when you get to too much, you got to do it again. So this is, yeah, okay. Because there's another one. Okay. In Abacus, when we do 2 digits, it gets a little strange because we sometimes we do too much or not enough. So you need to be flexible to either add and go back to the loop or to do the loop. That's what it is. You have to. Oh my goodness, we've been on for like 2 hours. Yeah. Oh, okay. Okay. Yeah. Yeah, this is a lot. This is a lot. The division and multiple. That's why I don't do division and multiplication just yet. You need to know this. Once you get to this, then we can start slowly going into it. That's why I try to increment, a little bit at a time. So that's why we did this part. But you have to know your second. You have to know your 2 steps. Yes, right. Do you know why? Yeah. So we do. Let's do uh, 12 times 9, right? So this is the beginning parts of understanding distributive property. I don't teach FOIL. FOIL is an acronym and it's not scalable. What we're doing is we're doing distributive property. Property. FOIL. First, it's an acronym. It's so dumb. Sorry, I shouldn't knock it. Outer, inner, last. Last. And it only pertains to if you have 23 times that by 24. FOIL means first, this one, this one. And then outer is this one, this one. Inner is this one. And then last means this one, this one. Yeah, so it's F O I L. First, outer, inner, last. It's just this. You take this number and you do this. That's all you're doing. That's all you're doing. I think FOIL is confusing, but it's not scalable because the problem is when you get to 3, 4, 5 times that by 3, 6, 9, what do you do? What's inner and what's outer? What's inner? It doesn't even matter. Even if you did 36 times that by 78, 78, 3, 78, 8. How do you know what's inner and outer? This only pertains to, I think, only pertains to 2 digits times 2 digits. What happens if you did 1 times 7, 8, 9? Or what happens if you did 3, 4, 7 is equal times that by 24? Now what do you do? I don't know. I don't like the acronym FOIL because it doesn't scale to more questions. Just like memorizing doubles, right? 4 plus 4, that is only a one, that's only very small number of stuff. It's not scalable. Okay, so going back to here, we still have to count our digits. 1, 2, 3. The reason why is because we need to know where to put our answer. 1, 2, 3. So we're over here. So 9 times 1, 9 times 1 is 1. 9 times 9 is 9. 9. 0, no, 0, 9. We want to make our 9 a double digit. So it'd be a 0 and a 9. Yeah, got it, got it, got it. Okay, good. So 2 times, and then the next one is 2 times 9. Add the 1, add the 8, add the 1. See, now you need to know, how do you add the 1 here? Plus the 1 is what? Yep, yep. See, you need to know your multiplication fact and your 8 and your addition. You need to know your formulas to do this. Hmm. Oh yeah, sorry, 108. Yep. Yeah, go back one column in 9 beads. You're exactly right. You're absolutely right. Because you know it's only 9 beads, you got to go back one column. Because we started here, but that's the technically the tens. We start with the tens, and then there'll be the ones. So because 9 is here, it'd be like that. 0, 9. Yes, yes. But yes, because no, because I'm doing this. This is my tens, this is my ones. This, but that's if you're on the abacus. These are two different, these are two different, because we don't need to say, we don't need to say 10 times 9. We don't need to say 10 times 9. We're only saying 1 times 9, right? So we're making it manageable chunks because that's why we don't learn our 10 times table, because it's redundant. That's why it's redundant, because 1 and 10, because the abacus tracks our number, we don't need to know, we don't need to worry too much about the 10 times 9. Yeah, 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 yeah. But because you, yeah. Oh, yeah. Oh, hold on. Yeah. The accumulation and stuff. Did I have it here? Yeah, yeah, yeah. So yeah, yeah. It was. I was trying to add in story to the numbers. I mean, it's not true, right? Because you can't go backwards. You can't say two. I don't know, two dinosaurs, because it'd be, I don't know. Yeah, it's not yeah. So I try to add the story to it, and I talked about the mother, father, and then they go to, and then what I wanted to do is I add the one here. You add one here, so you know you're just adding one to this side, and you're just adding three to this side. So I was trying to get more fluidity of like how to write different ways of multiplication. But thank you, I appreciate that. I was going to make this into another book. I was going to do separate books, twos, threes, fours, fives, six, seven, eight, nine. Those were the those will all be separate books because I don't like how they just combine it all and they just expect the kids to know it. So that's why I want to separate it. And so what I did here was I also wanted to go the reverse. So if I where is it? Like no. Yeah, so the reverse. So if I know 7 times 3 is 21, I know, and then I showed 7 times, so 7 plus 7 plus 7 is the same as the other way. And then because it's multiplication, I'm going to introduce division, which is just the missing factor of multiplication. So that's part of it. Yeah. This I haven't been on this for a little. It's been about a year since I've done this one. But what do you mean? Oh, teacher pay teacher. Yes, yes, you can get this on teachers pay teachers. Yes, yes, yeah. If you wanted this one, but I stopped at 3. I was trying to do more, but then I started getting I started going down the path of more adding and subtracting. Yeah, yeah, yeah. I have a lot of like ideas. I have a lot of activities. It's just taking the time to do it all. But yeah, my plan for the multiplication was have its own. That would be its own series for the multiplication, and then once you get that, then I was going to have a separate series to do mazes with multiplication. So you've seen this, and because I talk about it to the adults because they already know the multiplication fact. But yeah, but that was for specifically for the kids to make it more um, story like. Yeah. Really? Thank you. Yeah, yeah. Yes. Yes, it is becoming more automatic because you're starting to notice. Here's another thing. I don't know if you noticed. One last thing. When we did the, where are we? I'll just rewrite it. So remember when we talked about uh, the twos? Two, adding the two is plus the 10 minus 8, right? Plus the 2 is equal to plus the 5 minus 3. If you notice, 3 and 5 is equal to 8. Yeah, that was a cool thing about it. So 3 is the same thing. Plus the 10 minus 7. 3 plus the 5 minus 2. You see that? It's funny. It's amazing how simple it is. Minus the 9 is equal to plus the 5 minus the 4. Yeah, that's the pattern you can see. That's just how the formula works. That's just how the numbers work. I'm like, oh my god, that's crazy. But that's when you show that they're all related. That's why, yeah. Let me just finish it out. Minus 6. 4 is equal to minus plus the 5 minus 1. Right? So if we just get the numbers, that's how they're related. Well, I think it's just a novelty to see. But in the problem, you'll know that it's an adding of the 5 or taking with or adding of the 10. Whether or not you can add the 5, I think that's the thing. But I think for me, it was just a novelty on how they just kind of relate to each other. Yeah, yeah, just more ways of thinking numbers, and it's just interesting on how like using the abacus can show you the patterns because you can never see the patterns when you're writing it out, right? Because if we add the 10 or add the 10, take away the 6 is what, right? This is take away the 6. But notice it's also the 5 and a 1. That's what 6 is, right? Yeah, yeah. See? And that's the thing. Like you can write it, but it doesn't make sense. But when we want to add the 3, guess what? Adding the 3 is 7, right? Add the 5 and the 7, right? This is, yeah, yeah. That's the number pattern. Crazy, right? Yeah, it's crazy. Yeah, yeah. Yeah, it just solidifies, and again, it solidifies the concepts of your or your number bonds, your pairs. Ah, it's so amazing. It's such an elegant, simple tool, but it's amazing like what happens when you could see it. Um, yes, yeah. Ideally, is the visual presentation of the abacus. But again, because I've been playing around with and I notice, and then when I have my students, they started noticing things too, and I'm like, oh, that's brilliant. So yeah, yeah, yeah. I'm sorry for the headache. But yeah, I'll see what I'll see what I could do about the YouTube and make sure that we have both of them. I don't even know. Oh yeah. Okay, cool. I don't know if it's streaming or not, but I'll see. Cool. Yeah. No, thank you. It was so strange. Like people would watch it, and I'm like, huh. Okay, that's a lot of information all at once, though. I feel like, and a lot of information. But I just need to. My idea was just to get it out there because the more I talk about it, the more it's out there, the more reach I want to get. So I don't know. Yes, but yes, I do. I do. And even if I go live on all the other platforms, only like maybe two people are here. Hey, Diggy is still here. I got my graphite. Oh, sorry. Um, yeah, there's a person on YouTube, and I just saw the message. Anyways, um, what was I saying? Oh, yeah. So the way the algorithm on TikTok is very nice because they will just keep feeding you people, whereas the algorithms for TikTok and all the other I'm sorry, YouTube and all the other platforms, they don't help you go live, whereas TikTok helps me go live, and so I get an audience. See, like for you, yeah, what? Yes, correct, correct, and yes, and I have to repeat myself over and over again because there's people that come into the room and the people that leave the room. Whereas whereas it's different for this is the office hour. Like you're going to be here. Like I'm going to be here at 9 o'clock, and we start talking, but we talk from where we left off. So there's more of a continuation. That's why I enjoy having this as a separate time. Because I was thinking about doing TikTok at the same time here, but then it would be overwhelmingly always new same thing over and over again. We would never get to this part here. Does that make sense? So, yeah, I mean, you could watch the TikToks, but very rare do I start talking about epiphanies like this. Yeah, this is where I get the chance because you have a foundation. I don't have to teach you how to count. You know what I mean? So, you already have a foundation. You're already growing, so it's easier for me to leverage off that. Yeah. So, I mean, yeah, you could watch the TikToks, but I don't know. You could try to find like multiplication because I do the beginning parts of multiplication, but I don't do advanced multiplication. Oh yeah, the interest rates. Yeah. Yes. And you already know how to do it. Yeah. 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 Bring it all. Bring it all. Whatever you see, whatever you find, you want to talk about, let's do it. That's that was the reason why I wanted office hours. So yeah, that's the reason why I wanted office hours. So then you can bring in any question you want to talk about, like abacus, arithmetic related. Oh, that was the other thing. One more thing. Exponents. I was really excited about this because my kid is seventh grade. Like he's going into seventh grade. So I'm helping him and I'm like thinking, how do I abacify it? So what's an exponent? An exponent is just like 3 to the second power or 3 to the third power. That's all it is, right? So what is it? 3 times 3. Oh, I can do that. Not a problem. And then 3 times 3 times 3. So I just need to explain the concept. Oh, this one is 9. This is 27. Yeah. So what I would do is, what I was going to do is I was going to introduce this in Abacus where we have 9 and then times up by 3. And then the only thing that's different is what? I'm just explaining the concept, but they need to know their multiplication fact. And then I can add in any exponent. So I could say like 24 to the fifth power. So it'd be 24 times 24 times 20, So then it would just be bigger. Yeah. So I was thinking about adding that as the towards the end of the multiplication exponents. No, it's easy because you just need to break it up. That's it, right? You just need to break it up. When you break it up, then it's easier to do. And then you could do this on the abacus because you could just do 24 times 24, 24 times 24, do it again, right? Take this answer here, take this answer here, and then times it again. Yeah. And then yeah. And then that's what I would do. You could. You could. Yeah. See, and that's the same thing with order of operation. So I could also order of operation. I like order of operation better than what they say PEMDAS, or BODAS, BOD. I think it's this way. These are more acronyms. I'm like, that's so dumb. Yeah. So PEMDAS, parentheses, E is exponents. MD is multiplication and division. AS is addition, yep, and subtraction. So S, subtraction. So this one is brackets. Brackets is the same thing as parentheses. Just depends on where you are in the country, where you are in the world. I forgot O. I think maybe it's beddas because it's still O is E is still exponents. Beddas. I think it's beddas. Exponents. So the reason why I kind of stay away from the acronyms is because sometimes people are very adamant that you have to do multiplication first before the division. But I know order of operation. I know that if I do parentheses first, exponents second, third is a toss up. It can either be multiplication or division, and then the fourth is addition or subtraction. But some people are so set against that. No, you got to do division first before the multiplication. I'm like, why does that even matter? Because they're the same hierarchy. They're the same hierarchy. You know what I mean? So I don't know why somebody thought of acronyms would be the best way, but I don't like acronyms because it doesn't help this situation. Yeah, first, second, third, fourth, right? So yes, yes, yeah. But again, I don't do acronyms because people get stuck how we say it. Like foil. First comes like in foil, right? First, inner, outer, whatever. So it doesn't make sense to me. I see it more like just the patterns, I guess. So, okay. But again, I'm excited for exponents because I was going to introduce it after the multiplication, but that won't be until like afterwards. But it's going to be like a 4 or 5 page. It's not going to be a separate book because there's no point. It, yeah. So it'd be interesting to like even expand out to like say like the interest rate equation that I just showed you, PR. But then I would have to go into like algebra and stuff and see and kind of pick and choose what I can do and what I can't do in the abacus. At this point it's the concept, it's not arithmetic. So that's why I'm not sure if I'm going to go that route If I have time, maybe I'll add it in, but I'm not sure if I would. Because by here you should be solid in your arithmetic, that it should not be it, you should be able to just do this. But yeah, so you know what I mean? Like that's I think that's where I probably would not go, but I would show it just to show how it's scalable. Yeah. Yeah, it's been great. It's been fantastic. Yes, a lot of them. I have to review it and see where I can start like implementing and stuff. But that's the plan for the books and the path of the class. And so the it's different than what I have at the what I've been learning, because I feel like it's more inclusive with the mainstream. Yeah. Cool. Thank you so much. Um so I guess I'll see you next week. Yeah. Yeah. Yeah, so get your questions ready, and your word problems, and we can do more. We'll do more. Okay, cool. Thank you. Okay, bye.